So the purpose of this unit is to be able to solve equations, particularly equations that already have variables in the exponent, like this one does, or equations that already have logarithms in them, like we'll see later on. Here's the process for solving an equation like this. First, isolate the exponential, meaning I want this that has the variable in the exponent to be all by itself. Nothing added, subtracted, multiplied, or divided on the front or on the back. So this -3, gotta go. So a division, since it's multiplied, we'll do the inverse operation, leaving us then with the 18 to the power of p. And then over here, let's see what we get. So if I do -21.2 divided by -3. Now, here is where I need you to make me a promise. If your decimal comes out and stops, like if it's 7.2 or 8.367, stop. Those are okay to use. If you have to round it, like this one here, it's 0.7.066666 forever. You would have to round it if you turn it into a decimal. That means you need to leave it as a fraction. Please do not round in the middle of solving, or else your final answer is likely going to be off a little bit. So once again, do not round in the middle of solving. So what do? You just leave it as a fraction. No problem. Like here, let's reduce the negatives, right? Negative divided by negative is positive, but I'm just going to leave it as 21.2 divided by 3. No problem. We know that's a number. It's a little bit bigger than 7. Once your exponential is isolated, nothing else except the 18 to the power of p, we're going to switch it now to its log form. Remember, logarithm gives you the exponent. That's how we get the p by itself. So it's log base 18 of this number, the fraction, 21.2 over 3. For a final answer, so this is exact, but we'd like to have a decimal approximation. We're going to round to 3 decimal places. I believe that's what the instructions on your practice sheet say as well. So log base 18 of this fraction. Now, if you've got your Desmos, you can use your underscore. So log base 18 of 21.2 divided by 3 is approximately 0.677. So approximately 0.677. So we switched to log form. There wasn't really anything else to solve. So we just did the evaluation, got a decimal. Final step, check it, make sure it works. Now, depending how complicated your equation is, you may sometimes get an extraneous root, an answer that looks right but isn't. For something this straightforward, as long as we didn't make an error, this is going to end up working, but we should check anyway. So I'm going to go back to the original equation. So -3 times 18 to the power of, and we think that power is about 0.677. Now remember, it's a little bit rounded, so the answer won't be exactly -21.2, but it should be pretty close, which that one is. So I think we're in good shape. So while we give that a highlight, let's just recap the process. First, get that exponential by itself. No plus, no minus, no times, no divide on the front or the back. Then switch it over to its log form, and then deal with what's left. Check what you got to make sure things went okay. I'd like you to do this next one. Quick pause, unpause when you are ready to check. Did you pause this thing? I know some of you don't pause. I know you just you go and you let it keep going, and then sometimes I beat you and you haven't done the work. You got to pause this and do the work. That's part of the deal, my friends. All right, I want to get this by itself. So let's add the 9 over. So we'll have then 10 times 14 to the power of k is 79 plus 9 is 88. Right? Yeah. Next, divide by the 10. Now this is one where it's perfectly fine to go to a decimal. 88 divided by 10 comes out 8.8 and it stops. No rounding needed. So then let's switch to our log form. The exponent is log base 14 of 8.8. Okay, nothing else to solve. Let's turn this into a decimal. And tell you what, just for practice, I'm going to use my other calculator and the change of base formula. So the log of 8.8 divided by the log of 14, it was base 14, right? Yeah. Comes out to approximately 0.824. I hope that's what you're getting. We should, of course, check it. And to check it, always go back to the very original equation. So 10 times 14 to the power of, I think it's about 0.824. And then what was it? It was minus 9? Yeah, minus 9. And I'm hoping for an answer that is close to 79. There it is. The only reason it's not exactly 79 is because we rounded that answer a little bit. Okay, last one. Do a quick pause, unpause when you're ready to check your process. So let's add the 8 over 17 to the power of, I got a skinny mark. 17 to the power of x equals negative 8. Ooh, and there's going to be a problem, isn't there? So x is log base 17 of negative 8. But we've looked at it a couple different ways. Negative numbers inside logarithms simply don't work. This equation is going to have no solution. If you try and run it through a calculator, even using a change of base formula, you're going to get an error. That's okay. That just means that it doesn't work. This particular equation does not have a real solution. So it is all finished.